Plate tectonics. Geological research in the 1960s concluded that the lithosphere, which consists of the Earth's crust and the upper solid layer of the mantle, is actually broken into several parts. These partial plates float on the partially liquid asthenosphere. Along the edges of these plates, earthquakes often occur, volcanic activity is strong, and mountain ranges and oceanic trenches form. There are three types of plate boundaries along which plates slide: convergent, or destructive, divergent, or constructive, and transform margin. Convergent boundaries. The continental crust is 30 to 40 kilometers thick, while the oceanic crust has a thickness of only 5 to 8 kilometers. When the two plates converge, the thinner oceanic crust will subduct or slide under the thicker continental crust. The subducting crust can sink as much as several hundred kilometers, where it melts into the hot material of the asthenosphere. The continental crust is forced upwards, forming fold mountain ranges. At the boundary, an oceanic trench is created. This is how the Andes mountain range in South America was formed. If two oceanic plates converge, the older, denser plate will slide under the younger one. This is how volcanic island chains are formed. Oceanic trenches also appear along the boundary. This is how the Japanese archipelago was formed, with the Japan Trench running near the islands. As in the former example, the older, denser plate subducts, and the younger one is forced upwards and compressed. The formation of the Eurasian mountain range was the result of two continental plates converging. Divergent boundaries. When two plates are moving apart, they create an opening for molten rocks to rise up from the asthenosphere, which cools and adheres to the plate's edges. One of the longest mid-ocean ridges on Earth formed at the bottom of the Atlantic Ocean. The cooled basalt rose most prominently above the surface of the ocean to form the island of Iceland. Transform margins, or sliding boundaries. Some tectonic plates slide along their edges. This type of movement creates less of a change than the other two types do. The best example of this is the San Andreas Fault in California. Plate tectonics is the science that studies the movement of plates.